Okay, everybody, we're about to get started with some presentations. Feel free to grab a seat and make your way to the back where we have presentations that we're about to start. Grab a drink, grab some pizza, grab a seat, head on back. Okay, give everybody time to grab some seats. All right, how is everybody doing? All right, awesome. Good to have you all here. Thanks for coming. If you haven't met me yet, my name is Sam. Hello. I'm one of the organizers here at DEVx. Yeah, we got a couple of cool presentations for you. Just want to say welcome officially. If you're new, thanks for coming. If you've been here before, thanks for coming again. I really appreciate it. So a little bit about us. We are just simply a community of like-minded developers here in San Diego. We meet once a month to share, to grow, and also just to hang out. So that's really what we're about. We're just fostering great events and open source projects, or even non-open source projects, whatever you might be. As long as you're a developer, new, experienced, inexperienced, doesn't matter. We welcome you. Here is the list of our organizers. We have AJ in the back, myself, Sam, and then who couldn't make it today, Ezekiel and Zane. But they are also awesome. So big shout out to the organizers of this event and putting it together. We also might have a new organizer coming on board. Jonathan, raise your hand. Where are you? There you are. Cool. Thanks, Jonathan, for contributing. Appreciate it. Yeah. We are the ones that make this all possible. We're very open. If you need to help out, if you want to join, let me know. A little bit about where you're at. This space is hosted by Edge. Edge is a company building a crypto application, wallet, and exchange platform. Really focusing on making it easy to self-custody your funds If you're a big crypto enthusiast, that's really important to you. Also focusing on privacy is another thing, which is for very diehard crypto fanatics, that's very, very important. So big shout out to them for hosting this space. But also a little note that we are all open source as well. Full disclaimer, I'm one of the developers of Edge app. So you can check us out at github.com/Edge app. Check out our code. Also, edge.app is the website. So big shout out to Edge for hosting this space. So for those of you who don't know, if you want to get connected, our Wi-Fi is Edge Guest. Password is I like big bits, all lowercase. So if you haven't connected already, that should work for you. If you're having trouble, you can always holler. Also, restrooms are out the front door to the left. Should be no door code, but if there is, it's 1595. But it should be open. For those of you who are found us on like Google, ChatGPT, or any other place, and it's their first time, feel free to link with us on Luma. That's lu.ma/DEVxNetwork. You can follow our calendar. We have a whole calendar scheduled for the rest of the year, and you can make sure to make it to the next one. So really good for our upcoming events. Also, we host our monthly here, but we might also do some one-off events here and there. So feel free to keep a tab on that. So our agenda for today, you guys have already done the first part, networking, hanging out, and eating lunch. So hope you guys enjoyed the pizza and drinks. A quick note on our speaker presentations. We're running a little bit late. We usually start at 1, but we start at 1:30 just to give it some breathing room. But yeah, we'll do our speaker presentations. And then after our presentations, probably around 2:30, we'll do a little community announcement where any of you guys can come up and say why you're here, and share what you're interested in, maybe what you're currently working on, whatever it might be. We'll give an opportunity for you guys to come up on stage if you want. After that, we go back to hanging out, coding, networking, and we close the doors around 4. So feel free to stick around. There's no rush out the door after the presentations. You guys can feel free to like hang out and use our facilities for the rest of the day until 4. We have 2 speakers today. First speaker will be AJ, one of the organizers. He'll do a little short talk on Intro to Capacitor, Native Apps with Web Tech. So this is going to be interesting. If you guys use React Native or any of those tools, this is kind of an alternative to that as far as what I know. After that, we'll have a bit of longer talk by Rajni. He'll be talking about Bluetooth Low Energy App Fundamentals, which is pretty cool. Who all of here has heard of BitChat, that app? One person. 1, 2. Okay, cool. Jack Dorsey, I think he's a popular guy. You might have heard of him. I'm excited for this one because of that app, if you guys haven't heard of it. So maybe, we could probably hack together some little competition, maybe come up with a better name. But yeah, really welcome these 2 speakers to the event of the first. Let's welcome AJ to the stage to do our first presentation.
How about now, guys? Very good. So, like Sam said, my name's AJ. Hello. Nice to meet you if we haven't met yet. And today, I'll be talking about an intro to capacitor native apps with web tech. First up, who is this talk for? Web devs seeking to dip into native app development. Teams with existing web apps, or the curious. Did just repeat? Oh, okay, never mind. Why? Who and why are very similar words, now that I think about it. Why? Why would you use capacitor? Or why would you build a native app using your web technology? You want native features. There's just some stuff that are still bound inside the closed ecosystems of Android and iOS. Raw power. WebAssembly gets us really far, but not all the way sometimes. And just being listed in the App Store or the Google Play Store. Credibility, Goals. I want to share a tool I've been exploring. You get to access native APIs from your web app in 5 minutes or less, or your money back, guaranteed by Sam Holmes. Some background. Bridges. Everyone loves bridges. And that's how all these, this category of app works. You bridge the native runtime and the JS runtime. But classically, you would just pass messages back and forth, like with a text, and then serializing objects or whatnot. Yeah, lots of serialization. But the new ways are direct object references. React Native, they let you just directly reference a C++ object. And then also really careful multi-threading. C links, which is a framework by ByteDance. There's two approaches once you get your bridge out of the way. First is just one-to-one native components with your XML tags and then the actual constructed views on either iOS or Android. Examples of this approach are links, React Native, and NativeScript. Second approach is web views. You just have a web view, and oh my gosh, it goes backward all the way. There we go. Okay, you just have a web view, and you just have access to native APIs. That's the second approach. And the two big players are Cordova, which has been around since the time before, 2011 or something, and Capacitor, my current favorite. Some more background. So for one-to-one native components, it kind of looks like this. I think this is React Native syntax. You got your view, your text, and your button, and you click the button, and it increases the counter. That's what the market would look like in a React Native app. And that's what it gets transformed into, kind of this imperative Swift code or UI kit stuff. You can see it, label view, button view, and a container for the top level view. Meanwhile, for the web view approach, here's your web code, web markup, and there's your native markup. It's the same, and that's the real cool part. Now, here's what Capacitor is promising. It works with any static site, any static web app. The native project and the web project are equally important. With Cordova, you had to fully control all the native projects using Cordova stuff. It was kind of a complicated abstraction there. And a stable core ecosystem. So there's a set of plugins that are pre-built and managed by the same team that does Cordova. I'm sorry, Capacitor. Oh my gosh. What I promise. Web app to native APIs in 5 minutes. Or your money back. And so, demo. Get ready. Gotta present mode, mirror, change, entire screen. Oh, why is it? There we go. Is that big enough for everyone? You guys see that? Okay, actually, bump it up. I bumped it up. So, 5 minutes. Start the timer, someone. Thank you, Sam. Your money's on the line. Um, so first step, we're gonna make a minimal or like a demo Svelte app. Svelte is one of those languages. What was that? Hey, backseat driver. It's a web framework, kind of like React, kind of like Vue. So this is just creating the demo app for Svelte, and it worked. And let's run it actually. Ooh, there we go. Get ready. Ta-da! Web app. About page, some kind of game that's like the Svelte version of Wordle. It's a new to-do app. So there's our web app. There's like a counter just to show some interactivity. But now let us ignore those red marks and then follow the rest of this guide. First, you're going to install a couple packages. So just the capacitor packages. And we're only doing iOS right now because Android. Android is just a whole nother step that, remember, 5 minutes. That's really important. We installed capacitor packages, and now we're going to run npx cap init. What's the name? Oh, okay. Good. Success. Step 1 complete. Step 2, let's open up the, ooh, is that small? You can't really increase that size actually, I'm sorry about that. Just edit the config, and instead of dist, our static site is going to be located in build. And then actually build the web app. So pm build. Ooh, prerequisite. We need to install a static adapter. How's my time? Oh my gosh. So static app, and then edit the config to make sure we're using the static app builder. Okay, one more time. Get ready. This is it. Red. We're so close. We're so close, guys. You have no idea. There's just one step. So it turns out one of those pages was a server-side rendered page, and you gotta remember this. Capacitor only works with a static web app. Static, please. And once we do those magic words, static, please, there should be just one more thing. Time. 3 minutes, okay. There's some magic words. Don't enable pre-rendering and don't enable SSR just for this demo. And now, get ready. Red. What does it say? What does it say? Ship it.
Routes must be fully renderable.
Ooh. I prepare. Wait, what? There's a colon somewhere?
Colon space false.
Oh, that's a good idea. That's okay. I prepared for this, and I have a turkey already baked. It's in dust. Oh man. So there was a couple more steps that we're skipping over, but essentially pm run build, npx cap add iOS, npx cap run iOS, npx cap sync. Those are the commands I would run had my demo not failed. You owe everyone money now, I'm sorry. But get ready. Oh wait, npx cap run iOS. Something better. This pre-baked turkey is really working out for me. Oh, this is a good part. Don't worry, guys. iPhone. And this is the fun part. We wait for it to compile.
It's gonna take 5 minutes.
Really? Oh, dang. So what's our time?
It's this game. 5
5 minutes, but fine.
I'll be okay. Any questions while it's compiling? Hey,
How big are the apps? Because like Swift apps are enormous compared to Objective-C. Are these big fat apps or are they
so the question was, are these big, fat apps compared to Swift?
PHAT?
Hey, there's a thing there. There's a counter, and it's a web app, and static site limited, similar text, but yeah, there is a web app running in iOS. Yay! And to answer your question about bundle size, I don't know, man. I didn't look at that into that metric. Any more questions?
You could check. Is this exclusively with using SpellKit then?
So, the question is, does capacitor require SpellKit? And the answer is no. All you need is 3 things: index.html, a capacitor config, and a package.json, and to install these, other packages. But then you can take any like plain JavaScript web app, or Vue or React, and build something native. Okay, and yeah, Ben.
Yes, thanks for remembering my name. Do you know any companies using WebViews for their production apps?
Sure. There's a couple of companies that use capacitor. Burger King. That is the poster child, I guess. Fidelity. Their app is a capacitor web app. And I think there was one more, but you can ask me afterwards, and I will maybe remember. So last part is native APIs. I'm just going to show you what that looks like in the counter. Okay, is it big enough?
Yeah.
It's big enough, okay. So we imported preferences from capacitor preferences, and this just accesses on iOS NS user defaults. And you'll see right here when we initialize a component, we get something with key count, and then if there's a value there, we set some local state to that value. And then every time that value changes in our local state, we set the preference. And with that, we're able to like quit the app. Is it like this, like double? Oh yeah. And it'll come back. Yay! Is that the same number?
Yes.
Okay. And there's the demo. Yeah, so that's what I promised. Sam at DEVxSD Network.
That's not even a real email.
Yeah,
You're familiar with Electron?
I am.
It's the web network or web tech for native apps on desktop. This is the same, seems like they're using the same name but for mobile here.
Yeah, I believe Capacitor also will spit out a version suitable for Electron.
Cool.
Was that a 5-minute timer?
Yeah.
Thank you.
Hey, you did it.
Oh. So a couple gotchas. You might need to learn some Swift or Kotlin. You can't get all the way there sometimes. I don't know, maybe some business logic. Maybe you need to do something crazy. Additional configuration. Oftentimes you're going to install like a capacitor plugin and find out they need you to set like a preference, or sorry, a permission or something. String like, hey, we need your location for these reasons. Yes, permissions. Or capabilities. You just either like in your Xcode project or Enter project, you need to indicate that you're using these list of features like backgrounding or location. And some more caveats. Mimicking native feel. This is just a quick list that I will post in Discord later, but to fill the screen and avoid double tap zoom, you just add some values to your viewport content. So viewport fit cover and user scalable no. So that way the user can't like click one of your buttons and zoom in on it. That's really weird in a native app. Disable pull to refresh with overscroll behavior none in CSS. Avoid the notch with a safe area inset top. So like your nav could be below the like that weird thing they have at the top of iPhones. And then prevent haptic touch previews using this bit of CSS right here. So when you tap an image and it does like a thing where you can share it or whatever, that's also weird in a native app. Thank you. Sam L. Holmes for your money back. Well, what is your middle name?
It's half of it, but yeah, come talk to me. I'll pay you, and everybody gets free pizza vouchers for the next event.
Woo! Any more questions?
Does it automatically grab dark mode?
You said automatically dark mode?
Yes.
No? I mean,
There's gotta be a plugin for that.
I'm sure there is. You in the back?
Developers need
Xcode
Xcode licenses?
licenses. Yes, you do. Well, to actually,
To the store.
yeah. So the question is, do you need an Xcode license? You do when you want to publish. Thank you, Jonathan. But not to like build it or test on your own stuff. Or Android. It's like $20 or something. Way cheaper. Okay. Thank you.
Thank you, AJ. And next we'll have Raj welcome up to the stage to talk to us about the Bluetooth Low Energy and how to use that. So everybody give a warm welcome to Raj.
Can you check? Yeah. Hello, hello. Okay. I think so. Okay. Let me make a little bit bigger. Okay. Hello everyone. Myself Rajni, and thanks for coming. And I hope everybody is doing good. I'll be talking about building apps for BLE enabled devices. First, I was going to ask like what is BLE, but I think you already mentioned in the tagline. So, yeah, I can change the question like it's a Bluetooth low energy. Do you know like how it's different from like a normal Bluetooth devices? Or anyone having BLE devices right now along with you? Which one?
My phone.
Apart from my phone. Your phone. Sorry? Yeah, so headphones are Bluetooth Classic mostly, but yeah, it's Bluetooth device. Yeah, that's a BLE. Yeah. Smartwatch. Smart ring. Yeah. Okay. Yeah. So it can be like phone or even tracking device. Yeah. Smartwatch, heart rate monitor, or even like smart appliances or door lock can be a Bluetooth low energy enabled device. Oh, sorry. Okay, so about myself, I'm Rajni Kedia, and I'm working as a staff engineer at Hinge Health, building cross-platform application for BLE devices. And outside of work, I love working on crafts and making IoT stuff with my kids, like for hobby. And I would like to quickly show some of my past work. Okay, yeah. So this is something that I built as part of my Hackfest project, like basically like Nintendo Switch, like a Joy-Con. So it made of cardboard and have a IMU sensor so that we can play a game in mobile. And the next one is this, again same, like a steering and pedal. I can show a quick video for that. So this is IMU sensor that I'm having, and then I just put it inside this cardboard controllers. Yeah, so just using 2 sensors and using that pitch and roll values, just like a fun project.
So you're detecting acceleration on the gas pedal by the depression based on the angle of the.
Yes, they call it a pitch.
Okay, so it's that sensitive, huh?
Yeah.
Wow.
Okay, one question. Anyone knows one-shot golf game? Have you ever played that game? Oh, I thought. Yeah. So this is the game that I worked on. So it's like from your phone. You can real time play golfing robot games. So all the robots are in like a warehouse, and from any part of your world, we can play this game. Unfortunately, the whole company shut down because of the funding. But this is, I just mentioned because this is one of the interesting projects that I worked with. And again, this is IoT kind because it works with like a camera, a WebRTC feeding, and also like a it's called real-time communication using I forgot the name. SignalR, like a real-time communication. Okay, so this is about my past work, and let's get back to the slides. Okay, so today's agenda is first introduction to Bluetooth Low Energy and why we chose Bluetooth Low Energy over other alternatives. And then we'll go to like how it actually works, and then available APIs in different platforms because it's available on like Linux, Mac, Windows, iOS, Android. And then we'll go through the common challenges with the BLE. And then last we'll end with demo. Okay, so Bluetooth. So Bluetooth is a wireless communication protocol, and it's owned by a special interest group, which is like a separate entity. And they don't manufacture the Bluetooth low energy or Bluetooth classic devices, but they just govern like how the protocol should be defined, so that each manufacturer can align with that protocol, and the devices can talk to each other. And Bluetooth low energy. Okay, sorry. Okay, yeah. So this is comparison about the Bluetooth Classic and low energy. So communication in Bluetooth Classic is continuous, and it's like a heavy stream data. For example, I mentioned the streaming, like a audio streaming. So headphone, they uses Bluetooth Classic. Bluetooth low energy is a short data, like for example, heart rate monitor, like a small chunk of packets. So that comes under Bluetooth low energy. Range wise is almost same, like 100 meter, but in Bluetooth low energy it can be more than, it says 100 meter, but in some cases it can be expanded to more than 100 because we can design the firmware like keep the radio frequency low, and that it can send a smaller packet to long range. And data rate is energy wise, yeah, this is the main difference. Energy wise, Bluetooth Classic is 1 watt, but Bluetooth low energy is like 0.001 to 0.5 watt. Data rate almost same. Even Bluetooth low energy have 2 Mbps in last like Bluetooth 6 specification. Latency wise, yeah, this is also a big difference. in Bluetooth Classic, it's like 100 millisecond latency, but in Bluetooth Low Energy, it's 6 millisecond, and the reason is like a smaller packet size, so it's fast to travel. Voice capability, Bluetooth Classic, yes, like headphones. Bluetooth Low Energy, this just started, I think, a couple of years back, like with Bluetooth 5.2 to Bluetooth audio, so that we can also develop app with Bluetooth Low Energy audio. And starting Android 16, like latest Android, they also added support for Bluetooth LE audio. Hardware and development cost wise, Bluetooth Classic is higher because it needs the complex chip, and Bluetooth Low Energy is low. It's almost like $1 or something per chip, so it's relatively low. And development cost wise, Bluetooth Low Energy also low, because in Classics you need to have like a sniffer, like a very complex sniffer that will inspect the Bluetooth communication packets and yeah, see what's going on. Okay, so why BLE? I think most of the things is already covered in the past slide, but the major points are like battery consumption. Again, it's very low. Cost is low compared to other Bluetooth Classic, and yeah, this one point is available on mostly all modern devices, like all the device manufacturer, for example Android, iOS, or even in Android, Google, Motorola, Samsung, everybody has the support for this Bluetooth Low Energy, or even like MacBook or Windows also have, Linux devices also have support for Bluetooth Low Energy. Latency is very low, again we talk about this, and range, yeah, I think we also talk about this. Okay, so here is the interesting part, and I hope I will not confuse more, so I'll just use some of the devices to make it easy to understand. So in the center, it's a central. So central you can consider as a device or a system, like a MacBook, I'm sorry. And this is like a peripheral. So peripheral is something like will broadcast data, and central is something like they listen to data and will show. So for example, in heart rate monitor, you will be having a heart rate device, peripheral, and it will capture the data sensor and then send it to the central, your companion app. So these all are peripherals, like heart rate monitor, smart plug, smartwatch. ESP32 is like a small development chip for Bluetooth Low Energy, and in central it's either like a desktop system or mobile, which works as a Bluetooth central device, BLE central device. And you can also consider it as like a client server. So this can be a client and this can be server. So client can ask, okay, get me the heart rate data or get me the battery level. Then the server, the peripherals will resolve that request. Okay, I think the fonts are a little bit small, but okay, I can, it's readable, or I can make it bigger. Okay, yeah, so this is how the communication works. So for example, I'm taking left side as a peripheral device, like a heart rate monitor, and right side as a central app. So it starts with like your app will initiate a scanning process. So once the scanning is started, you will press a button on your heart rate, for example, like this, or this is not a heart rate monitor, this is for example, and it will start advertising. So advertising means, okay, I'm here and this is my this is my ID, or this is what I can do. So all this data is passed to the scanning function, and then it's up to the central to see to connect which device they want to connect to. So here, once they found the right match, it will just send a connection request, and then the peripheral will just reply with confirmation. So that's up to this. It's like almost communication is done. The last part is once its connection is confirmed, still the client or central wants to know, okay, what are the capabilities that you provide. So it's called like a request service and characteristics. We'll cover into the next one, but yeah, And then when they ask for the service and characteristics, and then it will reply back with the service and characteristics. Sorry, I missed this part. And then this part, up to this communication part is done basically. And then after that, connection part is done, and then after communication phase will start. So basically, it's like either your central device can individually read the value. So for example, hey, get me the heart rate value, get me the battery level, or it can subscribe to particular characteristic or service. So for example, if they subscribe to a device information, battery information, so whenever the battery goes up or down, it will get automatically pushed like a notification to the app. And then yeah, you can also write characteristics. So this also depends on the particular use cases. For example, in heart rate monitor, I don't know if there is a case for write, but there are some medical devices which we need to send a command. So for example, if I work on a chronic pain management device in which you need to start treatment and stop treatment. So in that case, you need to write characteristic, okay, start the treatment or stop the treatment. And then last is disconnect part. So in next slide, we will be discussing this like service and characteristics, because it's important with respect to like how the functionality is defined. Okay, so service and characteristics is the way how a Bluetooth peripheral exposes its functionality. So for example, if it's a heart rate monitor, it can have heart rate service, and each service can have multiple characteristics. So for example, heart rate service can have a characteristic called like a measurement or body sensor location or any other point, any other control point. For example, in the same device, there can be another service called battery service, which is like a standard service, and it will have a battery level information as a characteristic, and also power state like battery turn off or on. And this is another example, like a different device where they can have environmental sensing device like temperature, humidity, or UV index. So this way you can organize how a peripheral can expose some of the details to the client central device. Okay, so this is just a quick walkthrough of how I use React Native API for Bluetooth Low Energy enabled app. I use React Native BLE Manager as a package. So I think as you mentioned, like there is a third-party package to enable the native functionality. The similar way, React Native has their own package for BLE Manager. So I can quickly show how React Native works basically, because it will connect with AJ's talk. So React Native is almost similar to what AJ mentioned. The difference is that in Cordova or capacitor, this is a bridgeless. So bridgeless means when we call any function from JavaScript, it won't go to the web view. It will directly talk to the native API, like a native function. This way it will be way faster, and there won't be any like JSON encoding, decoding happen in this. And recently they released a new architecture which is like a bridgeless, which is like more powerful, like almost you can consider as like almost like near to native. So here is an example. So code will look something like this, like as a view, and then I will render a text like hello world, and then in Android or iOS it will almost look the similar, except like the dynamic island or like safe area constraint. Otherwise it will be like almost same. And other good part is like it would be real time. So if you make any change here, it will be automatically hot reloaded to take the effect of like what you changed there. Yeah, I think this is basic React Native thing. And here how I use React Native BLE Manager is like first, this is all the JavaScript code or TypeScript. So you call like a start method, basically this will initialize platform level API. So for example, for iOS, it needs to check whether the plist entry is added for this iOS functionality, or for Android, it may check whether the user has granted the permission for scanning or connection on Android device. And under the hood, they use this native API. So for example, when I call scan function on the BLE manager on this package, for iOS it will actually use core Bluetooth, and for Android it will use Bluetooth GET services, which is the native API for BLE stack. So again, this is almost same function that we looked in that communication flow. Start is like the central will check, okay, what are the device available nearby, and once it will be available, we will have that as a callback here, so we can connect to it. So once it's done, we can initiate a connection request from the client to the server, like a peripheral. And we also want to stop the scan. This is important because if you keep a scanning process running, then it will drain your battery, because it's like a battery heavy task. Retrieve service, this is also important. Like after you get connected, the central will ask peripheral, okay, what the service or characteristic you have. So this is needed, and once it's done, we have everything like a characteristic ID, peripheral ID, or service ID, and then you can do communication APIs like reading, writing, or start notification, like basically subscribe to any particular service or characteristic. And once anything change for this characteristic or service, then we'll get updated value here, so we can update the UI or write our business logic accordingly. Okay, some of the challenges with BLE development is BLE stack is different in each platform. So as I mentioned, like so Google, Motorola, Apple, they all have their own manufacturing BLE stack. So what I mean is they follow the SIG protocol and standards, but still they have their own logic implemented in their BLE stack. So one example I can remember is when Android 15 started, our app was live on the Play Store, but as soon as a user updated their device, their OS to Android 15, our app broke because somehow the read functionality was not working. And then we found that starting Android 15, Android replaced their BLE stack. They just totally changed to a new implementation, and new implementation was very strict about reading frequency. In our case, we were reading at very fast rate, like every 50 millisecond to get like a smooth animation for the sensors. Then we need to make adjustment and then make that reading a little bit slower and adjust with other operations so that we don't have that concurrency issue. So yeah, this is something we need to keep in mind. iOS is fine because iOS has like one manufacturing, like the BLE stack is almost same across all iPad or iPhone or even Mac. Testing and debugging is hard because sometimes you will get issue on your device. So for example, here on device, and then you don't know, you have app, but you don't know what's going on the device. So you need a sniffer or kind of a on-device logging that you can send a command and fetch that and upload to the backend to track any issues. Also, sniffing is also not easy. Like sniffing means your Bluetooth device is talking to your app. You will set up another system to sniff that packets using Wireshark or other tools, and that also required another antenna to sniff that device communication. Sorry. OTA is complex. OTA means over the air update. So it's same as like when there is a new update available for iOS or Android, you will get update, okay, new update available, and the images will be downloaded on your device and you will use that. Same way, there may be you add a new functionality or to devices. Mostly in medical devices, these are the most frequent cases. You add a new treatment or you add a new characteristic, then your device need to be updated. So your app need to talk to cloud to check, okay, what's the latest image, like firmware image for this device. If there is a new one, then we need to pass that to push that to the BLE peripheral device. And this also have a separate process, a set of command, because it's not like the same like communication protocol that we earlier discussed. It's like we need to put the device in a bootloader state, put new image, swap it. It's a bit complex, so I won't go into detail, but all I want to say is it's a complex process and it's totally apart from like normal app side development. Connection issues can be tricky. Yeah, so this will relate to the manufacturing thing. So for example, you are having your phone connected with this device perfectly, but let's say if you take a Motorola phone and try, it's not working fine because of their BLE stack differences. One actual real-time issue that we faced is like on LG Fi, we were not able to connect the Bluetooth sensor, and then we were not sure like what's happening. Then actually the customer figured out like how they found a way to unlock this. So the issue was when they are in this connection issues state, they will just drop down, like pull down the notification bar, and by doing that it was putting Android OS into a low mode state that will give Bluetooth energy more resources. It's hard to imagine, but that was the issue that was actually happening, because once they release a new version like LG Fi, and they fix this, and without app change it worked perfectly. So we need to be aligned with like what the OS updates are, or what's new BLE stacks that's being updated for a particular platform. Okay, so yeah, okay, I can start with the demo. So I'll be building, I'll be showing you the app where I build a central app that will be talking to one of the sensor. We can use two sensor, but yeah, we'll start with one, and then I'll be using this same BLE manager library, and then we will have another demo using like Swift to talk to macOS and maybe iPhone or Bluetooth Low Energy. Okay. Okay, so this is my React Native app. I can quickly show you how it's organized. So here there will be Android and iOS folders. So this will be like actual native APIs that will be here, and this is the node module. So these are the dependencies. So React Native BLE manager will be part of this node module, and whatever we will write, it will be here in like a TSX file or like TypeScript or JavaScript file. So you can see here in this is an entry point, and when it loads, I will just return the app content. So this is app content is basically returning this screen, and this is like where I wrote all the React Native BLE manager code. Yeah, so first I will import that module by this. Like I want to use BLE manager and other like definitions from React Native BLE manager, and then let me actually start the demo. Yeah, so this is the same screen that's rendered by this scan device screen. And first I will start with the scan operation like scan that we saw earlier in that slide. So let me start that. So it's scanning started, and we can see there is no devices available, but as soon as I start it, it will see this sensor. And this is RSSI, like a signal strength. So if you see, if you go nearby, it's going up. So basically it's minus, so going up. But if you go like farther, then the number will go down. And we can use this to measure the distance, but RSSI is not very accurate because of the other noise. So this is just to make sure, like if you are very nearby and with no interferences, we can use RSSI to like basically approximate distance. Okay, it's nearby 1 meter or not. Okay, when I click, it will show the device. So when I click that, I'll actually initiate a .connect method, which will give me some basic data, and then I can do another read request. So when I read, it will read the serial number, firmware version, battery level is still not there because it's a separate read request, and then RSSI. So when I do battery, you can say it's a 41%, and yeah. So in start roll, so what I'm doing is I'm reading that sensor values, so roll values, and just basically reading that characteristic which is reading the roll value from this sensor, and then just displaying into like a converting into angle, and then displaying. For this, I need to start a loop like every 50 milliseconds or something. I'm reading this. This is not actually what we do in production app. This is just for like a demo purpose, because this will drain your battery if you are having like a repeated like every 50 millisecond loop. Generally what happens is, like in your medical device or any other device, you will have this defined as a notification, like a notification. So whenever this changes, your peripheral will push the data to your app, so the app doesn't need to keep polling about that new updated values. Okay, I think the last demo is about using Mac API, like a Mac OS API and iOS OS API to show the connection. Okay, so here you can see the target. Oh, it's too small. So here I don't know it's readable or not. Plus, oh, you said control?
Hold down control and then no, probably not. That's an access.
Yeah. Anyways, I can read it. So here is the same app. Same project, but here I'm creating two targets. One for peripheral. So I'll be running peripheral on this device, and I'll be running central on this Mac. So here the central is selected, and I will just start the central here. So this is a central device, and here I'll start peripheral on my iPhone. Okay, so this is peripheral. Okay, so first I will do is, like currently it's advertising, so I'm just stop advertising. First I will on my central app, I will start the scanning. Okay, so it will just start scanning for nearby devices. So as soon as I start advertising, it will find, okay, there is a new device available nearby. So when I connect it, it will get connected, and then it will read the device name. And this is to show how we can do notification, like subscribe and notify. So this central is subscribed to this value basically. So whenever I change this value, oh sorry, okay, whenever I change this value, it will go, it will push to central device or Bluetooth low energy channel. Same for like decreasing, it will go down. Yeah, so this is just to showcase like Bluetooth low energy development across all the platform. I'm still missing one platform, which is Android, but unfortunately I need to like wipe my system yesterday, and I couldn't install the Android SDK. Otherwise the same React Native app could work for both iOS and Android. And let's get back to yeah. Also, I'm working on another library called React Native BLE Peripheral Manager. So this is same as the library that I use. The only difference is that this will help to build more peripheral devices for your phone. So for example, if you have if you're working on a medical device, and if you want to test something, you don't need actual hardware. You can use iOS or Android peripheral APIs and use React Native to make a single app, and that will work for both. And you can basically make your phone into a peripheral device. So for example, if you do send a notification or set a heart rate value, your central app can validate, okay, it's working fine over Bluetooth low energy channel. Thank you everyone for quietly listening to me. This is honestly first time for me, but I hope I tried, and also my presentation is educational purpose only. I use medical many times, but by any means it's not about like building a medical devices, because medical devices, it's not easy. Like there are many regulations like FDA and like quality check you need to pass, apart from actual like API coding. So yeah, and any questions? Also before question, I just wanted to share that I work at Hincheld, and he is currently actively hiring for front-end and back-end engineers. So feel free to apply here or connect with me or scan this QR code. And yeah, questions? Yes.
In your macOS iOS example, you said when you press the plus and minus button on iOS, it sends to macOS. But on the macOS side, it's updating the number without the iOS changing, right?
So that was just
Can you
like
repeat the question as well? Repeat the question.
Sorry.
I didn't. Can you repeat the question as well so we can hear?
Yeah. So I think he's saying that even if I was not doing plus minus, the number was doing up and down. Yeah. So that demo was meant for like heart rate, like fake heart rate monitor. Actual communication happens over the Bluetooth. Why I did that was because it doesn't look like you're exactly following. It should be like a smooth transition. So I can start again the demo. I understand the confusion. So for example,
It was a simulated data stream.
not simulated data stream. It goes up and down from the last data sent. So what I mean is,
Synthetic.
Are you injecting voice?
okay, so here I know it's 99, right? Oh, I think I'm not sharing my device screen. Good catch. Okay, so I'm doing nothing. It's 100, so it will just go like a 99, 100, or 101. So let's say I'm doing. Okay, so it just go up between 124 to 126 or something. So it's still actual data following through, but for the like display purposes, I was trying to make this cleaner, but couldn't get enough time. But what I want to make sure, like this is like a, let's say, companion heart rate monitor app, and you see the smooth transition basically. So whenever you change this is like a updating. Yeah. Does that help answer?
So what you're doing is you're receiving the stream from the iOS, and then those coming as notifications, and you're applying filter on top of it.
Yeah.
To smooth out transition, but then right now it's oscillating up and down around the number that you're.
Yeah, that's correct. So whatever number is there in this 156 is passing to the central, but it's just for animation purpose, like doing plus and minus. Yeah. Yeah. Any other question? Yeah.
I'll go ahead and speak in the microphone. So my question is, do BLE transports handle a lot of like signal noise or any of the issues in like lossy data? What sort of transport are we working with when it comes to BLE? Is it more close to something like UDP or more like TCP, where you get more guaranteed packet receives and sends?
Yeah, that's a good question. Though I'm not too deep into how the actual data transfer in like a physical layer, but the way Bluetooth work is Bluetooth Low Energy especially work is like they work on a 3 channel, like out of 40 there are 3 dedicated channels that they can hop in between. So even if there are noise, they can hop in between these 3 channels, so to reduce the noise. Otherwise, I think if you compare with
So just to interject, yes, BLE uses retransmission at the
oh yeah. Yeah.
So TCP.
Yeah, thank you. Yeah. No, you. Sorry.
Oh, me. Okay. So authentication. In normal Bluetooth devices, you have to like pair, like go through the pairing process, and I didn't see you do that on the BLE devices. Is that one difference?
Yeah. So for this purpose, I wanted to make it very simple, but yeah, it's an important part of authentication security. So how it works is like if you have a medical device, peripheral device, and you don't want to be available to any Bluetooth central app, like any developer can create an app and just access the device. So what's the normal strategy is to set encryption and make secure some of the characteristics. So whenever, for example, any central device will ask for the serial number, because that characteristic for serial number is marked as secured, it will raise a PIN error or security error. So on that case, your app will ask for that 3-digit number or 4-digit number that we see, right? Like you need to enter some PIN number. So that way, or there is also another option. Like when that happens, your app can talk to your backend and get the actual code that you want. So you don't need to manually enter it. So once that is set, that characteristic is marked as secured, but you provided a password or kind of authentication, like it calls like a pairing or bonding, that this app wants to pair with you, and you press accept or don't allow or allow, right, depending on iOS or Android. Then after that, your communication is marked as secured until you again forget the device from Bluetooth settings. Yeah, I don't. It's a like whole topic in its own, so I didn't add into this communication flow. But yeah.
So it's a BLE feature. You can mark some.
Yeah, it's
characteristics.
yes. Yeah, I mean it needs to be implemented into firmware. So I'm saying firmware because most of peripheral devices software is written as a firmware on the board. So yeah, that firmware need to add a security feature to mark particular characteristic or service as a secured one. Yeah.
Can BLE peripheral devices communicate directly with each other, or would it always go through the central device?
It's always go to the central because it's like a client server. So yeah, it always go to the and like I think you mentioned like a bit chat. So I haven't explored like how he implemented, but he uses the mesh technology. So mesh is like a broadcast, like everybody is open. I can send message to any nearby Bluetooth instance and they can store it or just send it. Though the data is secured, but the benefit is like you can do the networking or communication, especially like isolated area or emergency situation without actually turning on your network.
So they relay.
Yeah, relay. And they have some timeout. So after some time, it's like expired. So
And that bypasses central devices closer to
yeah, there is no central device in that concept. Yeah. You had asked a question.
Well, another question, yeah. So for notifications, is there a maximum payload size for the notifications you need?
Yes. So it's called a MTU, like a maximum transfer unit, which is generally 512 kilobytes. So it's a maximum that you can transfer. But depending on manufacturer, you can also set or request, okay, hey peripheral, I'm setting this MTU. If you are allowing, we can agree on that communication. Like each packet should be maximum this MTU side. Yeah.
I see. And then is there a maximum frequency of notifications?
Sorry.
Is there a maximum frequency of notifications that peripherals can send?
Frequency, what do you mean by like like
Let's
how
say
frequent?
Yeah, let's say I have an audio streaming use case. I have a microphone that is on a peripheral device. I want to stream all the audio onto a central device, and then that seems to be quite high bandwidth. How do we combat that?
Sorry, I have no idea on that. Like, especially the yeah.
Just to clarify, the 512K sounded really high to me. It's 512 bytes, not K.
Oh, sorry, bytes. KB is like yeah, it's bytes. Sorry. Okay, any question?
Can you get the list of properties quickly, conveniently of what your laptop or your phone has? So we can see if we could use your laptop accelerometer as a steering wheel for a game on your phone.
Oh yeah, you can.
MacBook wheel.
You guys are a bunch of techs in here. Your life revolves in laptop and gadgets, right? Like the internet.
You should have an HD
Exactly.
TV as your monitor.
Yeah, you guys are a bunch of techs, and then your life revolves in internet and technology, right? Makes sense.
Was there any other questions for Rajni? I think that does it. All right. Well, give a healthy applause for Raji. Appreciate it. Okay, before we all get up and leave, let's quickly close out. Yeah, let's just give one final applause to our speakers today. It was always appreciated for the content. Lastly, announcements. We like to open up the stage to anyone who is new or wants to, share some of the things that they're looking at as far as like projects or ideas, anything that to your heart's content that you want to share with the community. You can also share like other events that you're also attending or interested in. You like to share to invite out. We also like to mention, who knows what current a Roman Empire means? That meme, no? Okay, so current Roman Empire. Ed wants to know, so I'll explain it. There's this meme a while ago about that went online, where supposedly men think about the Roman Empire every so often, and their significant others would always ask, hey, how often do you think about the Roman Empire? And they'll say like at least once a week or every day. And so it went viral as a meme. So I kind of use it as like, hey, what's the current thing that's on your mind every day? So I call that your current Roman Empire. If you want to get up on stage and say, hey, I really like AI this or crypto that or whatever it might be, it's your chance to share. Do we have anyone who would like to share something with the community? Okay, we'll start in the front. Welcome. Yeah, cool. feel free to introduce yourself and tell us what you
My name's Mark Alejo. I'm very new to coding. I've been trying to teach myself for about a year. I'm in a coding boot camp and a coding mentorship. Currently working on a VS Code extension, detect code tech debt, and implementing an AI agent to help refactor the code. I used to be a firefighter one with CAL FIRE and left that to pursue to be a software engineer. And that's currently all in my mind, and I would really like to play Warhammer. That's about it.
Yeah, come on up stage. Oh. Oh. Nice. First fighting fires, then fighting technical debt. I like it. The real fires that we all end up dealing with every day, huh? Tony, did you want to get up on stage? Cool.
Real quick, I'll be doing a presentation here in a couple weeks at the React JavaScript event for AI pipelines on-premises stuff. So if you're interested in that, check it out on Meetup.
All right. Anyone else want to share, introduce themselves? Sure. Welcome on stage. Cool.
Hey, hi all. I'm Anishek Kamal. I'm a solution architect by profession. Been in industry for 10 years, building data and AI solutions and designing them as well. Recently started working on a small idea. I think I've spoken about it with a lot of people over here. The idea's name is DEVxSD. It is, starting my founder journey. But what we're trying to do is help people get out of debt faster. Our website is up at debt0.club. Is it possible to pull it up? But we are still at like pretty early idea stage, trying to get some more validation. And yeah, we are building a prototype, debt0. Yeah, that's correct. Yeah. So website is up. We have a wait list right now. We have around 320 or 330 people till now. So happy to get your feedback. Connect on LinkedIn. Looking to connect with like-minded people and developers. Hopefully, sorry, I was just get side, but yeah, that's me. Thank you guys.
All right. Tech debt and real debt. Cool. I like it. Anyone else? Okay, Jonathan.
Hey everyone, I'm working with a company now that's looking for some SEO help, SEO and Google AdWords assistance. So if you have experience with SEO or Google AdWords, let me know. Or if you know someone that you might recommend, just say something to me, say hi, let me know. The other thing I'll mention is Sam and AJ and the other organizers put their personal money in to pay for the drinks and the pizza. So if you are comfortable donating a little bit, I think there's a sign over there with a QR code. It's like, hey, we appreciate donating $5. It's much appreciated. That is all. Thank you.
Thanks, John. Appreciate it. Okay. Anyone else got anything they'd like to share? I think, did I see one other hand? Did I not catch? AJ, come on.
Hello. I did a co-working meetup on Friday. Angel was there. It was pretty fun. Gonna do another one in La Jolla. Little Italy. At Bird Rock this Friday. So come on down. Oh. Yeah, just a couple hours, work on your projects. It'll be at 1 to 4 at Bird Rock in Little Italy. Smile. It shall be posted today and be on Luma.
Follow the Luma, guys. All right. Perfect. Cool. Okay. I think that was everyone except, yeah, no more hands? Okay, cool. Except for, I had one thing that I wanted to say is my current Roman Empire. If you guys want to talk to me about it, I would love to talk about it. The thing I can't stop using and get off my mind is who here has heard of this? Okay, a lot of hands. Okay, one hand. I love this tool. I've been using it over Cursor and other things. For those of you that haven't heard of it, it's an AI agent terminal app similar to Claude Code, but all open source. So I really love that fact, and it's got a thriving community. And Ed is also, you've heard of it, or did you want to?
So, okay, so I learned about Luma, so I can use that for my own calendar. So, just take a moment here, if you don't mind. I assume that should just pop right up. HDMI, USB-C to HDMI. Okay, there. So, I have an event coming up on Friday and on Saturday. Just meet on the border there at the mall in Escondido. And then another one, practical knowledge and skills, where we can talk about things, share what we know. So, Friday, September 12th, and Saturday, September 13th. So, starting at 4 o'clock on Friday and starting at noon on Saturday. So, you should be able to look me up on Luma, or you can come talk to me. Okay?
Awesome stuff. I love that there's more like side events and community coming together. That's what this is all about. So yeah. Thanks, Ed. Appreciate that. Yeah, so check out Ed's in-person events as well. Yeah, I just want to shout out Open Code. They're really awesome what they're building, and I've been loving the development. And if you guys want to learn more about that, I would love to talk your ear off. If you just already know about it and you want to talk to me, that's what I'm here for. So that's kind of like current Roman Empire, I guess you could say. On that note, closing note, whoop, boop, boop, there it is. Whoop, there it is. Okay. That's it. Follow us at DEVx.network. You can find our Luma, all of that information. You can also submit a talk if you're interested on coming up with some material and presenting. Join our Discord community, which will be on there as well. And yeah, follow our event calendar for the next meetup and other side meetups. So with that said, let's close with, feel free to grab some more pizza, some drinks, hang out, and I just want to thank you all for coming and making this community awesome. And I can't say how much I appreciate people attending. So thanks again. And yeah, feel free to hang out. We close at 4. So.